Hello everyone, let's talk about another medium problem on Leetcode today, sum of square numbers. In this, we are given a non-negative integer c. We have to decide whether there are two integers a and b such that a square plus b square is equal to c. Then they have given some examples as well. So when c is equal to 5, we return true because there exist two integers 1 and 2 such that 1 square plus 2 square is equal to 5. While when c equal to 3, there is no such solution possible and we return false in this case. Before going into the solution space, let's look at some more examples. Suppose c is equal to 1, then will we return true or false? The answer is we will return true because 0 is also included in that answer because 0 square plus 1 square is equal to 1, right? So that is one thing to keep in mind. Also, when suppose c is equal to 2, will we return true in this case or not? Answer is again yes, because what we can do is we can do 1 square plus 1 square and that will return true. So a and b actually can be equal and a can start from 0. And what is the largest value of a and b can be? It will be square root of c, because we can say 0 square plus root of c square is equal to c in case c is actually a perfect square. Now that we have understood it, let's jump into the solution space. Let's think about how we can actually solve this problem. One of the naive approach to solve this problem is to take two integers a and b and loop from 0 to root of c and add a square plus b square such that we find c there. And if we find such pairs on the way, that means we have found our answer, we return true. But if we couldn't find such number such that a square plus b square is equal to c, then we will return false. But the time complexity in this case will be O of like root c square, right? So it will be O of c, right? And the question is, can we do better? And the answer is yes. Like if you think about this problem, it looks actually very close to the two-sum problem, which we had covered earlier, where we are given an array and in target we try to find two numbers such that they add up to the target. In this problem, think of this target as c and think of array as numbers from 0 to root c. Now let's see how we can actually apply the two-sum solution here. In two-sum solution, we try to find out two pairs a and b in the array such that they add up to t. And the way we solve it is like we actually iterate on the array, assume that a number is a, and we already know the target. What will be the value of b in that case? B will be t minus a. This is where hash set comes into the picture. So for every number a, we will look for t minus a into the hash set. And if we find such pair, that means we have found our answer. Similarly, in our problem, what we can do is we can actually loop from 0 to square root of c. In this case, it will be 6. The integer value of the square root will be 6. So this is the maximum we can actually go to for the value of a. Initially, a will be equal to 0. Then what should be the value of b? It should be c minus a square, which is 45 minus 0. So it is 45. But does it exist in the set? The answer is no. So we will just continue and add a to the set in this case. Then a becomes 1 and we try to find out b equal to 44 in the hash set. And the answer is again no, right? Because 44 does not exist in the set. So we will just continue and add 1 into the set now. Now our a becomes 2 and we check if c minus a square, that is 41, exists in the hash set, and the answer is again no. So we will also add 4 to the set now. Then we will be at 3 now and we will check does 36 exist in the set, and answer is again no. Now 9 will be added to the set, and now we go to 4 and check for 29 existing in the set because 4 will be 16 and 45 minus 16 will be 29. So we will check if 29 exists in the set, and the answer is again no. Similarly, we reach 5. Now we look out for 20 in the hash set and the answer will be again no. Now comes the interesting case. Now a is equal to 6 and that is 36, right? And but we already added 9 to the set. So that means we now found a pair such that 36 plus 9 is equal to 45, and in this case then we will return true. In terms of time complexity, it will be O of square root of n or square root of c because we are looping from 0 to the square root of that number. In terms of space complexity also, it will be O of square root of n, right? Because we are continuously adding square of all the numbers to the set. That will again take O of square root of n. But the question is, can we do better? And answer is again yes. Think about it. Do we really need has set in this problem to actually save these results? And the answer is no. Because if you look, the array is actually already sorted. And we can actually use a two-pointer technique to actually select two numbers a and b on the left and right, such that a square plus b square is actually equal to c. So now let's look at the same example using the two-pointer technique. So we can see that initially L will be at 0 and R will be at 6. At each step, we will actually calculate current. So current will be equal to left square plus right square. So we add those numbers. And if those numbers are actually less than C, that means we increment our left pointer, right? Because as the array is sorted, the value actually increases when we go from left to right. But if that number is more, then in that case, we will actually decrement the right pointer, because as the array is sorted, when we move from right to left, the values will be smaller. Now in the first iteration, we can see that 0 square plus 6 square, in this case 36, is less than 45. We should actually increment the left pointer. So L will be now at 1 and right will be at 6 still. So now we get a sum equal to 37, but it is still less than 45. So we will move the left pointer to the right. Then L becomes 2 and the current number or the sum becomes 40, which is still less than 45. So we will again increment the left pointer. Now we actually come at 3. In this case, actually 3 square plus 6 square is equal to 45. So in this case, we actually found our answer and we will just return true. This was a positive example, but suppose if we couldn't find our answer, when should we break out of the loop? Remember, in this problem, A can actually be equal to B. So we should at least run the loop left less than equal to R. But as soon as left is now more than R, that means we have covered whole of array. There is no unexplored territory in this array. So we can, in that case, return false. In terms of time complexity, it will still be O of square root of n, because the left pointer in the worst case, for example, can go from 0 to the right pointer or vice versa. And in terms of space complexity, it will be O of 1, because now we are not using any extra space. Now that we have understood the solution, let's jump into the code part. So we will just define the two pointers left and right. So left will be equal to 0 and right will be equal to integer value of square root of c. Now we will just run the two pointer technique such that left is less than equal to right, and our current c can be into left plus long of right into right. So first thing to note is that we are actually creating current as a long variable because there may be a chance of overflow. And second thing is I'm also using the long here because when we do left into left, it can also result in integer overflow. So better to convert it to long and then only add it to the current. Now, if current is less than C, in that case, we will just do the left plus plus. Else, if current is more than C, we will just do right minus minus. Else, if either of the cases is not true, that means it's equal. So we will just return true. But if we are out of the loop, that means we couldn't find the pair and we will just return false. Now let's run this code. Awesome. Now let's submit this code. Cool. I hope this video was useful to you. If it was, please like and subscribe. Have a nice time. Thanks again.